Thank you very much. I'm not sure if it's really rocket science what I showed today. It's more really grasp what we see, how security architectures are developing in today's world. And probably you have seen some of the content already today in all the other presentations. I will try to stay focused on changes which are relevant for the whole architecture, not for one special threat, one special virus, or one special attack vector. One of the things we see which is relevant today is, of course, and everybody knows, is bring your own device. And this is not only because of authentication and identification, it's also because we know that from an inbound point of view, we don't have this device under control anymore. So this is a significant change to the past when we talk about laptops from the company and things like this. And the other thing is, of course, that we have to protect the data which is going out. Not everything is ready to land on a personal device from me or from a colleague or whatever. So this is much more important also for outbound traffic than for inbound traffic. Second thing is Web 3.0 or it's 3.0 or 4.0, doesn't matter. Webification of the application is a relevant thing. Why? The complete architecture changes and things we have done in the past around TCP, around network zones, doesn't work anymore. One of the minimum things is that we have to understand additional protocols, not compared like in the past. We have to understand the complete HTTP protocol. We have to work with this. This is a significant change. And the other thing is that we are not able anymore to rely on, let's say, secure connections. So we don't have under control what is happening between an open device and an open application in the past. So protecting zones and protecting the special server doesn't work anymore in every case. The third thing is the expanding perimeter. Cloud, moving applications around, again a significant change because again we don't have the complete connection under control. Protected connections, VPNs, things like this are much more difficult to establish than in the past. And if we are really, if somebody is really, like this is seen in this example, if somebody is really willing to move applications in very high frequency on very different layers within the clouds, then he also has to be able to move the security instances together with the application, which is something we are not used to do in the past. So two basic things, and I don't talk about, as you see, about the traditional network. The traditional network remains the same like in the past. The big changes are the endpoint on the one side, which we don't have under control anymore, and the other end is the application. When we talk about resources, I don't talk about a special server or a signed network connect. I talk about the application. This is the significant change. When we look into what we are doing today, there are a lot of threats coming up, much more than in the past. Other sources, you heard about this and you will hear about this the rest of the day. I don't go into the details. The really important thing is that we see much more threats attacking the application and not necessarily the network or the server or a connection. So when we look into the top threats, almost every of them is going in regards to the application. So when we take an example, like DDoS for example, in the past it was pretty simple to work against synflots. So all the attacks which were attacking vectors with handling the amount of connections and things like this. It's much more important to handle attacks like slow low-risk SQL injection, where we are not able to really protect in a lot of cases the application itself. For example, the software which is handling the web server, because they are protected sometimes by securing mechanisms like SSL. So this is a significant change, and this significantly changes the world how we're building architectures we have seen in the past. Now this is something which is pretty traditional. It's only a small example, and it's not talking about some things like identification, authentication. It's a pretty simple example how we have different devices with different tasks in our security architecture today. And some are taking care of DDoS attacks, some are taking care of the web application, some are taking care of identification, not to talk about traffic management in between. So this is something which is really complex, talking about all the tiers within the hierarchy of security. It's expensive, because we have to use different systems, we have to manage them, we have to maintenance them, all of these things. And it really doesn't work out because every single instance is only taking care for a part of the problem. So most of the security appliances or software instances which are running here are only knowing their special area of interest. They know a special area of text, they don't know the endpoint, the end user device, they don't know application health, things like this. So this is usual architecture today we are working with. And if we are able to do this, if we are able to moving around this information about endpoints to other instances, then this is a lot of work and brings a lot of complexity into our environment. This is the reason why we today are still focused more on network when we talk about security than on applications. Knowing that the application area is the real target of attacks today and probably much more in the future. What we see today, and talking about something like Slow is a pretty cheap software which you can buy for some dollars and which you can use on a laptop, and it's able to break down every single firewall, every single enterprise server running a security software. Only $100 and a laptop. So this is something which is developing very fast, and on the network side, threats are becoming less and less. Why we are doing this? Basically, we are doing this because we don't know enough details about traffic. We don't know the content which is hidden in the traffic I have to handle today. You can compare this with a border, with a lot of people doing border control, and a bus, tourists, things like this. So the bus arrives at border control. There's one guy is looking for the bus. Is it the right vehicle? Does he take the badge? Does he pay toll and things like that? Next guy is looking for the travelers, passports, things like this. Next guy is looking for baggage. Is there something hidden in this? Next guy is looking where does the people go? Next guy is looking where does the people come from? So a lot of different security instances. Everything is doing something else, and most of the people are not knowing what the other guy is doing. Because they don't know enough about all the different areas which are related to this bus. Now, if we would have one guy which knows everything, where does the bus comes from? What is in the baggage? Where are the people coming from? Where are the people going to? What is the history of the people? What is the status of the target? How is traffic between border control and the target? This would be much easier for him and much faster to do this. But he has to know a lot of things, and this is one of the major changes we see in the security area. So what we see is that we have to know the context in my traffic or regarding my traffic when I want to do security. We have to know client information, so very detailed, high granular endpoint information. We have to know the traffic content itself, which is the closest area to what we have done in the past. And we have to know the application health, because we have to know where is this traffic going to, where is this application located, within my traditional data center, within the cloud, wherever it is, how is the health status and things like this. Looking into the client context, that's what I talked about. Is this a private device? Is this a company device? Is it protected? Is it infected? What is done with the device in the past? Are there games on it? Is it allowed? How is the operating system? Things like this. In the best case, also geolocation, things like this. The traffic, this is the traditional thing. So how is the traffic built? What is hidden in the protocol? What is the content within the packages? Things like this. And the last thing, application health. I talked about this. What is the application software type? Is this the right address where the traffic has to go? Is it allowed for the traffic to go there? Is it allowed for the endpoint? So the whole span of traffic control. This is one of the examples where most firewalls fail. Because most firewalls don't know application health status. And most firewalls control in regards of security, but if something is safe, they forward everything to the application. And it doesn't matter if this application is available or not, or if the performance level is high enough or not. And this is something, if you have one single instance controlling every piece of this traffic, of the endpoint and of the identification of the application, then you are able to manage this. what is the things we see? It's back to the future, I would say. It's something we have had in the past. It's an architecture which is, and one piece is building architectures built from full proxies. So if I like to know everything which is hidden in my traffic, and if I like to know everything regarding the endpoint, the user, and the target, the application, then I have to break up the whole traffic, all the packages regarding all OSI layers. I have to profile every single package and every OSI layer, and then I'm able to identify every single thread which could be hidden, the number of threads, the address, where they are coming from. I'm able to recognize patterns and things like this. So if I'm able to do this in one single system, because then I have all the context in one single point of control, then I can verify if there is any security threat hidden in the traffic. And if I'm able to do this at the single point of control, this is important, through different layers, then I'm able to build within the single point of control everything which should be safe regarding my traffic. Now, is the single point of control one appliance? No, it cannot be one appliance. But it has to be a virtual or logical single point of control, so that I don't have to move around context information to all instances which have to verify for security. Looking again into this traditional data center, where mainly my network and my zones and my servers, my physical servers, are protected, this would help me if I consolidate all the things, context information as well as security features, in this one logical single instance. This instance knows everything about the context and is able to manage every security-related threat. The question is why we are not doing this. And this is something which is really, so why we are not doing this is there's a simple reason behind. One simple reason is performance. So if you have a single instance handling all the things, it must be performed like hell. If you look into a traditional firewall today, it's very easy to break this firewall with a higher number of open connections, yes, or with attack vectors based on amounts of pings or whatever it is. So this single point of control has to be very, very performant, much more performant than we usually use firewalls, without stacking them for different security reasons. So you have to have this high performance fabric or system or appliance, whatever it is. And this, in the same way, it has to be possible that this is a virtual one. Because if you are not able, we talked about Web.0 and perimeter move, if you are not able to move this single logical instance through your whole application world, which might be in your data center, but might be also at Swisscom or Colt or T-Systems or whatever, or Amazon, then you are not able really to protect your application in a very fast and simple way. So this is why this high performance fabric or platform can be a physical one, which is much more performant, of course, but also should be able to do this as a virtual one. The second thing is you have to have something like a management layer, which ensures you to have interoperability to all the stakeholders which in your, let's say, application management process. This is the middleware tier, so you have to have connectors to all the middleware tiers, you have to have connectors to the virtualization engines, you have to have connectors to the physical engines, for example, to network devices, traditional network devices, perhaps traditional high-performance network switches or fabrics. You have to have these connectors for third-party systems, so not only for one vendor, also for third-party, because only then you can use the power of this central logical instance to move applications around together with the appropriate security instance. And the third one is you have to have, we call it at F5, we call it business models, but it's more an ecosystem, an environment where you have to have to be flexible regarding licensing, for example. You have to move licenses around, you have to add and subtract features. So sometimes you have applications which are attacked for 2 weeks only. You have applications set up from test environments, for example, only running for 1 week. They are running sometimes in the cloud or in your own data center. So licensing and putting on and off features has to be very flexible and much more flexible than in the past. So this is the ecosystem, and this is something, frankly speaking, it's not available today, unfortunately, of course, because otherwise most of you would use it. But there are moves in the market, and I'm standing here for a company, of course, which is going through this direction, but other companies are doing also. And what we see, interesting things when we talk about cooperations between some traditional network vendors, for example, when we talk about virtualization vendors, there are joint developments and joint work to make this happen. And this is something which has started, so some of the things already can be done today, whether it's F5 or whether it's a combination of other vendors. Some of the things are still future, but this is a world where we see where the future will be. So what, as I mentioned, I'm from F5, and of course I have to talk about this a little bit, only short. Why we are doing this, and we are not more intelligent or better or more clever than other companies, but we have done this already in the past. So we have done load balancing based on full proxy technology. And if you remember, security gateways in the past always were full proxies. And only because of a matter of performance, they changed. And we didn't change. We didn't have had security features in the past. But when we used our load balancers for traffic management, so we really like to say traffic management and not load balancing, then it was always done based on full proxy architecture. So for F5 it was pretty simple to add security features, software-based security features to the operating system which is running on our devices. And because we have these 3 tiers, device, operating system and software feature, we are able, since 2 or 3 years, we are able to do everything of these features in a virtualized environment. This means we are able to move these things around, move this within the cloud environment, move this within the data center. We are doing this on your fingertips. That's what I say. So this is not a process of 1 week or 2 weeks. It's a process of 2 or 3 minutes. As I mentioned, other companies are going in the same direction, but important is that you have the base technology, so full proxy architecture, and you have all the connectors to the ecosystems around to be connected to the rest of your application world. One example which is real life, when you look, and it's same example like I used it in the how we protect our data centers today. You have different instances, different systems, different blade systems, different appliances, running different software pieces only to do DDoS protection. And as I mentioned in the beginning, this is very complex, this is very expensive, and this is not fast in terms of changes and flexibility. So, the things I talked about is consolidating this on one single device, and this is real life. This is something which is possible today. This is not future, but we only talk about DDoS protection in this case. We are consolidating all the security features on one single device, which can be 1 box or 2 boxes, which are clustered, or 3 virtual devices, which are clustered, managed by one management platform. And life is easier for you because you have to handle one management platform, you have to manage one logical device, you have to take care of only one instance of security, and this instance knows everything. This instance is even able to do authentication or identification for you. So this is really something we see in the past, and it's not because, as I mentioned in the beginning, it's not because of this game-changing behaviors. It's only because it's more simple, and if we don't do things like this, we will not be able to manage future application worlds in the traditional way we did, because it's too complex, too difficult, too slow. So this was the marketing slide. I skipped this. If you're interested in what F5 is doing, then colleagues of me are on the first floor, and we hope to answer every question. if you look forward to do something else beyond F5 or beside F5, and please keep in mind, full proxy is one thing, and connect us to the ecosystem, to the endpoints, to the application, to the other vendors you use. This is the second thing you have to keep in mind. Thank you very much.
Thank you.